within 3 units of negative 1. Remember that x plus 1 is equal to x minus a negative 1. Let's look at this example. This time we'll look at a greater than example. We want to solve the absolute value of 3z plus 1 is greater than or equal to 7. This tells us that 3z plus 1 must be less than or equal to negative 7, or 3z plus 1 must be greater than or equal to 7. Solving each one, we have 3z is less than or equal to negative 8, or 3z is greater than or equal to 6. And dividing both by 3, we have z is less than or equal to negative 8/3, or z is greater than or equal to 2. Looking at this in our set notation then, we're looking at all the values of z that are between negative infinity and negative 8/3, including the negative 8/3, and all values of z greater than or equal to 2, so that would be the interval from 2 to infinity, including 2. Now notice that in both of these problems that we had an absolute value isolated on one side of the inequality sign. Now here's a problem where the absolute value is not isolated. We have this 4, and we have this 2 over here, which we're subtracting. In order to use our properties, we first must isolate our absolute value. So the first thing we want to do is to add 2 to both sides of the inequality. And then we want to eliminate the 4, so we'll multiply both sides by 1/4. This gives us the absolute value of 5x plus 1/2 is less than 2. And we have successfully isolated the absolute value. Now, we can rewrite this as negative 2 is less than 5x plus 1/2 is less than 2. Why don't we pause the tape here and let you try to complete this problem. Let's look at the solution to this inequality. First, we need to subtract 1/2 from each part of the inequality, and then we need to multiply each part by 1/5. This gives us negative 1/2 is less than x is less than 3/10. So the solution to our inequality can be written as the open interval from negative 1/2 to 3/10. Now here's a problem for you to try. Notice in this case you have to do a transformation first. All right, let's look at our solution. Did you remember first to multiply both sides by 1/5? This gives us the simple inequality, the absolute value of x minus 2 is greater than 4. Now we can use our properties for inequalities and write this as x minus 2 is less than negative 4, or x minus 2 is greater than 4. And solving both of those, we find that x is less than negative 2, or x is greater than 6. So our solution set then is given by the interval from negative infinity to negative 2, union the interval from 6 to infinity. Now when you're working with absolute value equations and inequalities, remember the primary thing is to think. Let's take a look at these 3 problems. And I'm going to pause the tape and let you try to solve them. All right, did you find that there is no solution to the first equation? Here we're trying to say that the absolute value, which we know is not negative, equals a negative number. So there is no solution here. Our solution set is represented by the empty set. In the second case, regardless of what x is, the absolute value is always greater than or equal to 0. So our solution set is the set of all numbers from negative infinity to infinity. In the third case, we have an absolute value equation, but we have 0 on one side, so we have just the one solution, x equals negative 3/2. Now we can use absolute value definitions to help us write statements which involve distance. Here's an example. We want to write R is 5 units from 3. To do that, remember we're saying that the distance between R and 3 equals 5. And we would say that as the absolute value of R minus 3 equals 5. Now here's another statement. P is at least 5 units from negative 9. Now we're saying that the distance between P and negative 9 is at least 5. And we would write that as the absolute value of P plus 9 is greater than or equal to 5. Remember, P take away a negative 9 is P plus 9. And finally, if we have the statement M is no more than 8 units from 9, we would write this as the absolute value of M minus 9 is less than or equal to 8. Now, we can also look at some applications which involve absolute value inequalities. Here's a problem for us. In one winter month in Chicago, the daily low temperatures in degrees Fahrenheit satisfied the inequality the absolute value of T minus 15 is less than or equal to 10. Find the range of low temperatures that month. Well, this is an absolute value inequality, and we know that we need to rewrite it that T minus 15 will be between negative 10 and plus 10. Now, to solve this three-part inequality, we simply add 15 to each part. Our solution set, then, gives us the set of low temperatures which ranged from 5 degrees Fahrenheit to 25 degrees Fahrenheit. Now, let's take a look at this problem where we would like you to write this statement as an absolute value inequality. We're going to pause the tape and see what you can do with this. Okay, X is within 4/100ths of a unit of 2, then Y is within 1/1000th of a unit of 7. So we would write if the absolute value of X minus 2 is less than or equal to 4/100ths, then the absolute value of Y minus 7 is less than or equal to 1/1000th. Well, we have covered a lot of material again today involving absolute value equations and inequalities. Again, try to practice as much as you can so that you learn these skills. Have a good day.